Hi all, hope all is well. On today's video, I wanted to do a quick update in regards to my sodium hydroxide production. So in the last update I did, we were testing to see whether the sodium hydroxide was indeed sodium hydroxide and not sodium carbonate. And the way we tested that was by getting the recipe for a basic soap, and I went ahead and just divided it by 100, and then from that I've actually worked out a small portion, so it was 17 grams of oil to 5.5 grams of water to 2.5 grams of what I thought was sodium hydroxide. And now, as you can see here, this should have started to set, and unfortunately it definitely hasn't, except for at the bottom there. So you can just see that white film on the bottom. That is hydrolysis. So it is actually formulating with the oils itself. So the hydroxide is actually breaking down the oils, the lipids, and it is working. So the main thing is that we have confirmation that yes, the sodium hydroxide is indeed in the water itself. However, the concentration is not quite right. So I noticed the water was actually a little bit salty. You probably shouldn't taste chemicals or whatever, but I did anyway. It's not a bad way of actually knowing whether you've got salt water or sodium hydroxide. Sodium hydroxide tastes soapy, salt tastes salty, so it's not a hard one to go through that. And as you can see, like I was saying, there is a bit of a film on the bottom there. So it is, from what I can see, it is starting to work. However, the mixture is not quite right. So the best way to sort this out is, instead of using half a cup of that sodium hydroxide liquid, which is the liquid on the top here, so we're not doing the sodium on the bottom here. That's still uncertain exactly what that is. That may be concentrated sodium hydroxide. We're about to find that out today as well. However, instead of doing a quarter of a cup of the clear liquid on the top here, I'm gonna do a full cup, and I'm gonna break down a full cup, and then I'm gonna apply that concentration directly back to the 17.5 grams of oil and the 5.5 grams of water, and we'll see how it goes from there. Now, to actually go ahead and extract the moisture off it, so again, last time I just cooked it on the stove top here. This time I'm going to actually use the air still, and I'm going to collect the water off it as well. By the time I've finished with it, I should have clean distilled water that I could use for batteries or for drinking or for making coffee or whatever. And I will be left with salts in the bottom of here, very similar to the water desalination that I did with it, as you know, about 2 months ago, I think it was. So, best get to it. I will also be processing the white fluid on the bottom here as well. So, as far as I can understand, it's actually sodium carbonate, not bicarbonate. It's just sodium carbonate. That's because it's reacted with the carbon rods I use to actually do the electrolysis. However, I still have no confirmation on that. The only way to find out is obviously process the clear liquid first, and then I'm going to go ahead and extract all the clear liquid off it, and I'll process the white liquid on the bottom. I'll concentrate it, I'll run it through the still or in a saucepan on the stove top, and then I will combine it with some oil. If it combines really well with the oil, then it's an indication that it is indeed sodium hydroxide. As I was saying, I'm going to take the clear liquid from the top. This is not going to be as easy as I would hope, but we'll give it a go, purely because the white sediment off the bottom will want to come with it. But we only need a cup, so just pour it very gently. It's very exciting viewing. We'll speed this bit up. In fact, you can see the white liquid there coming down, but it hasn't quite got there yet, so leave that as it is. You can actually see the little bits of carbon in there from the carbon rods I used. That's it. That's what we're after. We're after 1 cup. That's not quite 1 cup. It's a little bit over, but we'll empty it out and we'll get exactly 1 cup in there. Now that we have our 1 cup or 250 ml, we'll go ahead and pour that into the air still. Go ahead and turn that on. You can actually just press the reset button here just to reset it from the last time I used it. Everything's plugged in and we are good to go. Who knows how long this will take. It is currently 10 to 2. Let's note the time. There's only a cup of water in there to process, so I'm thinking a couple of hours probably. 20 minutes later and we have fluid already. So it happened pretty quick actually. It's coming out in spurts, which is odd, but there it goes. It's exciting stuff. I've been sitting here for 20 minutes in anticipation of this. Now, believe it or not, this is actually happening a lot quicker than what I predicted. I predicted a couple of hours, I was way off. So obviously, less material in there being heated up means quicker extraction. So at the moment, we've almost got a full cup out of that, and we're only 40 minutes in, sorry. So things are happening very quickly. At this rate, another 10 minutes and we should be done. Okay, so we are 45 minutes in to the extraction process. We have almost a cup of fluid withdrawn from the liquid that we put into the still to begin with, and it has actually kicked itself off. So it's run dry. I should be able to crack that lid open now and have a look. However, I'm going to allow it to sit for a good 20 minutes. That way all the vapor that's left over in there, if there is any vapor left over in there, will actually settle down. Once that's done, then I can remove the salt from it and put them on the stove top, dry them out, and then we can give it a test with the oils to see if we've got sodium hydroxide. Should be mentioned at this stage as well, just how amazed I am at what's possible if you've given the right knowledge and the right equipment. For example, originally this started off in the H cell, where I produced sodium hydroxide in one side, I hope, and chlorine in the other, most certainly, that was confirmed. And then I've just gone ahead and literally extracted all the water from it as well. So not only, from, 4 litres of actual seawater, we can produce sodium hydroxide from it, we can produce table salt from it, we can produce chlorine from it, we can produce pure drinking water from it. Well, it's not quite pure drinking water, it's pure water. It's distilled water. So this water is so clean you can put it into a car battery. It's the same stuff you buy from a hardware store, or from your health food store, or even from your supermarket. But yeah, it's very, very easy and surprising how many items of value you can get from simple seawater. It's cool as. In fact, I'm going to break all the rules. I'm going to actually open this up while it's still warm. And the reason I'm going to do that is because I do not want any of the vapor condensating back into the device. So we're going to see if we can peel this off, like so. Make sure we don't burn ourselves. Get out of there. There we go. That's our salts that we've produced. Now, whether they are actually sodium hydroxide or pure table salt, I'm sure it's more of the sodium than anything, but we'll find out in due time. In fact, just having a whiff of that, it smells soapy. So it's definitely sodium, whether it's sodium carbonate, sodium hydroxide, time will tell. So as you can see there, we've got plenty of salts. So now it's just a matter of scraping that out. Once we've done that, go ahead and we'll add some oil to it, as we did last time. All right, so I'm just drying the salt out in a saucepan on the stove top. I can smell the chlorine coming off this, which is a bit odd. So obviously we had a bit of chlorine that come through the H cell. The membrane wasn't effective enough. And as that's the case, I'm guessing that the chlorine mixed back with the sodium hydroxide while it sat there overnight, and it actually formed salts again. So there may be sodium hydroxide in here. I'm probably better off trying with that white fluid on the bottom of the actual bottle itself, but at this stage here it just looks like a lot of salt. Purely out of curiosity, we're going to weigh it up anyway and just have a look to see how much we actually got out of it. So out of the 1 cup of fluid, of the clear, supposedly sodium hydroxide fluid, we have actually got 7 grams of potentially sodium hydroxide, more likely salt. So, but anyway, we'll give it a crack. So we're going to add that back in. So I'll go ahead and add the 5 to 6 grams of water. A little bit more. And that's the water we need. Now what I'm going to do is I'm actually going to use the water that we produced or extracted from the hydroxide mix. So we only need 5 to 6 mil of that. 5 to 6 grams, sorry. It's so easy to go over. 5, that's pretty close. We go a little bit more. 6 grams, that's good. We'll keep that to one side. In the Pyrex jar. Now we need our 17.5 of the oil. Like so. Now if this was fed in from caustic soda, we add that to the water, like so. It should, in all theory, if it is caustic soda, actually heat up, which it most certainly isn't. So this is a bit of a failure. That's all good. We'll learn from this. Maybe. Who knows? Anything's possible. We'll add that to the oil. And now for the next 30 minutes, it's just a matter of stirring it. And if we get a better reaction from this than the last batch that we did, then we know we're on the right track. However, I have my doubts. The next thing we should be doing is looking at trying to break down or extract the sodium from the very white material at the bottom of the actual bottle itself. And we may have better luck with it. Alright, so you can see here, obviously I've been mixing for quite some time. It's an interesting mixture actually. It's different than the last one again. It's become creamy in certain areas, as you can see there, and then remains very oily in other parts. So whether that's saponification actually happening due to the presence of some of the hydroxides, I cannot be sure at this stage. The best thing we can do is go on and try and remove that very fine white material from the bottom of the bottle and give that a go. Keep in mind this was 4 times as much of the hydroxide. So last time it was 2.5 grams that we added to the 5.5 grams of water and the 17.5 grams of oil. This time it was 7 grams. So you're talking, 3 times as much. But I fear that there may be a bit of salt in there actually. I'm surprised it's not mixing as well as the last one did. The last one mixed up very well. This one is remaining separated. So you can see there, the white is remaining separated and the oily material itself is just floating around the edge. It's odd, but an observation nonetheless. So it is very fine white stuff on the bottom here. That's what we're looking at removing next. Somehow I've got to separate it. I could do it if I had a siphon or a large syringe of some sort, like a battery acid syringe. I could reach down inside the bottle, extract that clear liquid from the top, leaving the other stuff on the bottom. However, I don't have that, so I'm gonna have to give it a go at trying to pour out as much as I can, just by gently tipping it out into this Pyrex jug. And we'll see how well that goes. Everything else has gone absolutely tremendous. Away we go. You can see it's creeping down there now, and I might let that settle for a little bit longer. Once it settles, we'll try again. So this is the third attempt to get the clear liquid off the top. I've gotten the majority of it off. You can see over in there. It's just that little bit left. And I'm thinking maybe I could leave it in there, but we'll see how we go. We'll give it another crack. Interesting to see how it layers. And I think that's about as good as we're going to get it. Now to measure out how much of the white liquid we've got. This will just give us an idea for future reference for whatever it is that we're removing from it. So just a little over 150 mil. Put that around. Two-thirds of the cup. And in it goes. It'll be interesting to see how this turns out. Hit that reset button, we're good to go again. So the still has just finished. We've retrieved basically 150 mil of water out of it. So we're shy by 25 mil. So it's well worth the time and the opportunity to actually take the lid off again. Again, this is extremely hot, but we'll give it a go. See how we go here. Oh, a lot more steam this time. And look at this, there's a handle here. This handle is not suitable for lifting or opening the distiller, which is hilarious. There's a handle, and you're not allowed to use it. Tragedy. Anyway, that's the way it goes. Righto, so there's a fair bit of vapor coming out of that. And that looks different. Completely different. Whether it's sodium bicarbonate or sodium carbonate, I'm not even too sure what the difference is at this stage, but I look forward to testing it. It's going to be awesome. Right, so now that I've actually collected the sodium from the still itself, as you can see here, it is slightly different than the rest as well. You can tell it's a bit more chalky in nature. So whatever it is, it most certainly is different than the sodium mix I was retrieving from the clear liquid earlier. So I look forward to actually blending this with some olive oil and a bit of the distilled water that I've collected over all my different experiments. So it's just distilled seawater. And yeah, we'll go ahead. We're gonna add, again, it's like 5.56 grams of the distilled water. It's gonna be 17 grams of the olive oil, and it's literally like 3 grams of the actual sodium, whether it's hydroxide or sodium carbonate. We're about to find out. We'll go ahead here, try and put the 5 grams worth in. Should be interesting to get it right, but we'll give it a crack. It's 3, and that's it, 5.5 grams. Now we'll add a couple of grams of the sodium hydroxide. We'll add that into this container here. Wipe out. Now it's only, we're looking for like 3 grams of this mix. And that's 3 there. 3 grams. I'll add the caustic soda to the water. And is there an exothermic reaction? Not that I can feel. So from what I can feel here, I doubt that I have sodium hydroxide. So it's back to the drawing board. And anyway, we'll give it a test. We'll go ahead and we'll add a 17 grams. All right, so this is batch 3. So this is the white material from the bottom of the bottle, as you've seen earlier. I've spent literally the last 20 minutes mixing this by hand, and I think this is it. This is finally what I'm looking for. This is soap. This is soap from seawater, which is absolutely amazing. So pretty much what I ended up using there was about 3 grams of the white sodium hydroxide I got from the bottom of the still. I used 6 grams of the distilled water, so I used the water from it as well. And I used 17 grams of oil. And from that, I've actually made a liquid soap at this stage. And I've tested it out in the water. And as you can see, my hands are pretty pink. It's actually doing exactly what it should be. It's obviously it's still a bit greasy there at the moment, but when you wash your hands under the water, it works really well. It washes straight off, which is an indication that the hydroxide is doing exactly what it should be doing. So at this stage, I think I've finally cracked it, which is absolutely brilliant. Really pleased with the result. However, I'm not going to stop here. I want to get this perfected, so I'm going to try and perfect the ratio until I can produce a solid bar of soap, as you'd find in your house, in your shower or wherever, in your laundry or sink. Or by working at the ratios, I should know for next time exactly how many litres of seawater will produce how many grams of sodium hydroxide. Basically, I should be able to go and get a bucket of seawater from the ocean, and I should be able to calculate exactly how many bars of soap I can produce, which will be absolutely brilliant. From that, I'll also be able to work out exactly how many litres of water I can extract from it as well, plus how many litres of chlorine I can produce. Now, by mixing it for like 20 minutes, you obviously get it all to react really well with itself. However, the ratio is definitely not 100% just yet. So if I let it sit for a period of time, so you're saying like 3-4 minutes, the oil will begin to settle back on top. So there's still unreacted oils in the soap itself. And as that's the case, I will need to add more hydroxide, so more of my refined hydroxide. I believe that by working on my electrolytic cell and by adding a tap to it, for example, so I can isolate one chamber from the other and stop the chlorine from leaking back into the hydroxide side, then I'll reduce the amount of salt that creeps back into the hydroxide side. And if I can do that, then I'll have a more pure sodium hydroxide. I also want to add more carbon rods to it if I can, and that way I'm producing more current through the actual electrolytic cell as well, and I'll be breaking down more of the salts, and hopefully having that tap there once the process is done, you isolate it, and then the chemicals remain in either side, so chlorine in the left hand side and your sodium hydroxide in the right hand side. But I guess time will tell. So something else worth mentioning, of course, is that right there. That's the first batch. That there was the second batch that was done on the same afternoon as this batch. You can see the colour difference between them. So obviously that was a clear liquid batch, that was a clear liquid batch, and that was the white liquid off the bottom of the bottle. And so far that's looking the most promising. The more I play around with it, the more I realise just how greasy of a product it is. So I will need to refine it further. And the best way to refine it further is to add more sodium hydroxide to it to actually break down the oils even further. So that's this white material here. So if I add more to that mix there, then we should be able to perfect the mix to the point where it hydrolyzes all the fats and produces soap. And I guess at this stage here, what I'll do is I'll keep it as it is, and I'm going to go ahead tomorrow or the next day when I get a chance. I'm going to do a fourth batch And the fourth batch will be the same amount of oil again, so 18 grams of oil to 6 grams of water. But instead of 3 grams of sodium hydroxide that I've collected, I'm going to double it and go 6 grams. And we will see what happens. Other than that, that's everything for this video. It was a bit long-winded in places. Whether you found it useful or entertaining or anything like that, I'm not entirely sure. But the main thing is all the information's here. I purely go about it this way so you can see the progress of everything I'm doing, just to show you that I'm learning as you're learning. Any mistakes I make, you'll be able to see it for yourself, and then you can see how we can work around it to improve our results. And that's everything. Cheers, bye.